All right, today we're going to pull back the curtain on the invisible rules that basically run our entire digital lives. Every single email you send, every show you binge watch, it all comes down to a fundamental choice the internet makes billions of times a second. So, let's just dive right in.
Have you ever stopped to think about this? It's kind of weird, right? A movie can glitch out for a second and, the show goes on. But if even one character was missing from your password, it would be a total disaster. Well, this isn't some random quirk of the internet. It's actually a deliberate design choice. And it reveals the absolute genius behind how our whole digital world is built.
And really, that choice, it all boils down to one critical trade-off. Do you need your data to be absolutely 100% perfect, or do you need it right now? Because here's the secret. You almost never get both. Different apps have totally different priorities, and the internet needs a system that's smart enough to handle all of them.
And this, right here, this captures the two extremes perfectly. On one side, you've got something like your banking website. You'll happily wait an extra half second for it to load, because every single digit has to be exactly right. But on the other side, say you're on a live video call. A few blurry pixels? Forgivable. A 5-second delay while the system tries to fix them? That would totally kill the conversation.
So, to solve this constant tug of war, the architects of the internet created two completely different protocols. Now, you can just think of them as specialized sets of rules, two different delivery services, if you will, and each one is a powerhouse, perfectly engineered for its specific task. So, first up, we have the protocol that puts perfection above all else. This is TCP. And I want you to think of it like the internet's own registered certified mail carrier. It's the one you use when the package absolutely positively has to get there intact. Okay, so TCP, that stands for Transmission Control Protocol. It has a very, very serious job. It sets up a secure connection, it numbers every little piece of data, sends it all in order, and then it literally waits for a confirmation receipt saying everything arrived safely. If anything's missing, it gets resent immediately. So the key takeaway here is, with TCP, you get guaranteed in-order delivery, no exceptions. And you can see why this is just non-negotiable for things like this, right? When a web page loads, all the code and the images have to be assembled in the exact right sequence to build the page correctly. When you're downloading a new app, you can't afford a single corrupted byte. TCP is the bedrock, the foundation that makes sure you have that kind of absolute integrity. Okay, but what if you need to just throw caution to the wind? What happens when you just need to get the information there as fast as humanly possible? Well, for that, we turn to our other friend, UDP, the speedy streamer. UDP is pretty much the polar opposite of TCP. It is built for raw, unapologetic speed. It's incredibly lightweight because it just skips all of TCP's formal handshakes and all that error checking. It just wraps data in a little packet and just sends it. It's what we call a fire and forget system. A few packets might get lost in the chaos, sure, but that's a risk it's willing to take to get the data there almost instantly. And this is where UDP absolutely shines. I mean, think about it. In a fast-paced online game, you need your opponent's position updated right now, not a perfectly delivered update that shows up a second too late. When you're streaming a movie, a lost packet might cause a tiny flicker of pixels for a millisecond, but the video keeps flowing. UDP is the engine that makes all these real-time experiences feel so seamless and responsive. So, we've got these two incredible protocols, right? The reliable TCP and the speedy UDP. But where do they actually fit into the grand scheme of things? Into the architecture of the internet. Let's kind of zoom out for a second and see how this amazing system is all structured. They both operate at what's called the transport layer. You can picture it like a 3-story building. On the very top floor, that's you and your app, your browser, your game. Down on the ground floor is all the heavy-duty infrastructure, the fiber optic cables, the routers, all the plumbing. The transport layer is that crucial middle floor, the logistics hub, where your app chooses its delivery service, reliable TCP or speedy UDP. But here's where it gets really fascinating. The transport layer is a master of logistics. It's absolutely brilliant at moving data from point A to point B. But, and this is a big but, it has one very specific, crucial limitation. It has absolutely no idea what it's carrying. And this is the real aha moment. The transport layer is just the delivery service. It moves the boxes, but it never ever looks inside. It can guarantee that 10 packets get to your computer in the right order, but it has no clue if those packets are a podcast, a picture of your cat, or a financial transaction. It's a specialist in movement, not in meaning. So, if the delivery service is just moving around raw, meaningless data,
how in the world does your browser know how to turn that data into a web page? Well, this brings us to the final and maybe the most important piece of the puzzle.
This is the job of the application layer. You can think of this as the rulebook that gives context and meaning to all the data once it arrives. It sits right on top of the transport layer, and its job is to take that raw stream of ones and zeros that TCP or UDP delivered and interpret it correctly. And these application protocols, these are names you've probably seen before. HTTP, right? That's the specific set of rules for web pages. SMTP provides the rules for how to format and send an email. Each one of these creates a specific kind of message, and then it just hands it down to the transport layer for delivery. And that right there, that is the beautiful, complete picture. The application layer decides what to do. Hey, get me this web page or send this game data, and it prepares the message. Then it hands that message off to a specialist, the transport layer, which chooses the right tool for the job, reliable TCP or speedy UDP, to handle the actual delivery. Each layer just does its one job perfectly. It's a beautiful system. So at the end of the day, the big takeaway isn't just TCP versus UDP. It's this elegant, layered system where each part has a very distinct responsibility. And this modular design, which was created decades ago, is what has allowed the internet to scale and evolve into what it is today. But as our world demands ever faster games, higher-res video, and more complex apps, it really begs the question, are these foundational rules still enough? What comes next when our needs for speed and accuracy start to push beyond what even these protocols were designed for?